today's experiment, we will be boiling an egg. So here I have a pot of water that I'm going to first take the egg and place it carefully into the pot.
Yeah, and the water has to get to be above the egg so it can be cooked fully and can be hard on the inside, not soft.
Now I will carefully, remember, turn on the gas. It is not turning on. And it is on. With a lot of smell. And now we will wait for a few moments for the egg to boil and the heat to go through the shell and make the egg cooked. And
The heat to warm up the water, then the water to actually cook the egg, which will be convection.
Yes, convection. Yeah, go. Michael, move to the side.
Alright, so as you can
Okay.
see, the water is now boiling and like cooking the egg.
Means the water is 100 degrees right now.
100 degrees Celsius.
Celsius.
And the water is basically practically boiling because due to the radiation given off by the fire here, which is cooking the pot,
And the
the
convection
pot
by
is-
water.
and the pot is cooking boiling the water by
Convection.
conduction.
Conduction.
And the water is cooking the egg by convection.
And you see, because the water's heat capacity is 1, which is like it gets heat faster than the egg. The water is actually heating up the egg right now, because as we can see, the lower the heat capacity, the higher it cools down, and the higher it like gets hotter.
And since we're adding heat to the egg, basically the egg is getting cooked by denature, and denature there's 3 ways to cook
Denaturing
it.
the
Is by
proteins,
adding heat, adding salt, or just adding acid, right?
spices and stuff.
Yeah. So yeah, this one way is cooking.
And also boiling it and having the water above the egg ensures the hardness of the egg of being cooked on all the sides equally and not being like soft or like liquidish.
So
So now-
what would be the result of the egg?
The result of the egg would be like it would be cooked,
It'll be hard
a hard egg cooked ready. And now
because
let's
of
turn off.
denature. Because it's denaturing, the protein the protein straight will just basically be changed and making the egg harder.
no, let's empty the water now. We have to cool the egg before we actually.
Those dirty pots.
And now we add cold water. Caesar, put some cold water. Just to cool the egg a little bit.
And explain the heat transfer in this.
Okay, now we put the cold water on the egg. Since the egg is already hot, we put the cold water, so the cold water would actually make the egg would cool it down from because it would change its heat capacity. Let's see now. Okay, so we got the egg right now. Okay, open the cold water, Susan, to cool the egg down. Okay, just cool it down a little bit. Okay. Now let's just break it a little and leave it for the heat to come out a little bit.
And so it would go at room temperature?
No, it would keep cooling down until it goes back to its cooked temperature, to its like fixed temperature. So now let's see how the egg is. Where's the trash either?
So this is kind of similar to the potato
Yeah.
experiment.
Yep. The egg is still a little soft because you're supposed to leave it boiling for like at least 1 minute.
So we're about to cut up the egg to see the result of the boil.
See? See how the egg is still liquidish on the inside? And you see like some of it started to harden, but most of it stayed liquid because we didn't leave it boiling for enough time for it to harden. Like the potato, as we saw in the chapter. So this right here actually still has some bacteria in it. So the good thing to eat it, to like ensure that all bacteria is dead, to actually cook it until the egg is like hard and dry and has like no liquids left in it.
And the yolk inside is actually kind of not that yellow, but kind of whitish as well.
This tastes better though anyway. Alright.
These are some ramen noodles, cup noodles, and we're gonna and we're gonna make them, and not with the boiling water, but now with the microwave. So first you're gonna put some water, and it's safe to use these waters because when it's heat, the heat will kill all the bacteria. There's no need to worry about that. So you're gonna push that much water.
Up to the line.
Up to the line, yeah.
Up to the line. I'm gonna eat this afterwards.
All right. Now cover it.
Now you're gonna cover it. You open it up.
It's already open, dude. What are you
Oh,
talking about?
So you're gonna put this in,
Make sure to close it. Tuck the thing in.
and the radiation.
Tuck it in. Tuck it in.
It's fine.
No, it's not. This is my house.
Here. All right.
And the radiation will cause it to be cooked.
But the microwave isn't actually healthy. The radiation actually gives cancerous diseases if you stand in front of it. It even makes the food worse
Hey,
too.
how much time did you put this again? I haven't cooked.
Just put it 2 minutes, yeah.
I haven't used this in a long time.
All right.
We're back. And so basically, this is being cooked by radiation waves, and this is actually really bad for you because all radiation waves just makes like your food like 3 times bad because what it contains.
Alright.
So it's preferably you just use regular fire in the oven to cook it.
It's done. The phone doesn't get hot, so don't worry.
I know. And calm down.
You know why?
Use as insulators.
Why doesn't it
They're
get
used
hot?
as insulators.
Alright, here you go. Get a fork or something.
Yeah, put some tapatio on this.
Just so you know,
Oh.
food-wise, ramen
There's
noodles
no
are pretty
fork.
bad for you. They're pretty like 50% salt.
It's sodium.
Yes, sir. Same thing.
There we go. It's all cooked
Here
and
you
everything.
go. So this has been cooked by radiation of the microwave, and the egg was cooked by conduction and convection. So these are the types of ways we can cook food. And yeah, all right.
Wait.
What?
Gotta give you guys a helpful tip. If you guys like cup noodles, you have to use this. You have to use this.
Actually, no, don't use.
Use this.
Hello, today I'm going to be talking about Boyle's Law, the one on pressure and volume. And as you can see here, we have a container and with a balloon in it. And what we hypothesize is that the balloon will expand if you suck air out of it because of pressure inside the outside and inside the container are the same. So when you suck air out of it, the atmospheric pressure will change inside the container, therefore making the balloon blow up. It also works the opposite way. If you blow air into it, it will shrink the balloon. Therefore, because the volume is expanding. So as you can see, the balloon it started to expand and not expand because of the pressure changing inside the container, getting more and less pressure and more volume and less volume. So yeah.